Okay, does it work? Hello everyone, and welcome to a talk about the update of what happened in the Scala, in the IntelliJ Scala plugin since a few years ago. In fact, I feel a bit intimidated now of standing on a platform here looking at you. The last time I gave a talk like this was a few years ago, then the pandemics happened, and now we had a break, and now I feel as if I'm making a talk for the first time ever again. And it's a bit like that with the IntelliJ Scala support as well, because we were here on Scala Days last time in 2019. A lot of things happened since then. We worked on many new features and support for new Scala features. And yeah, this is what this talk is about. But I would like to start with some data. Every year, JetBrains is making an ecosystem developers survey, and some of the data that we are gathering this year are already present. We got this year about 1,300 responses from Scala developers, and the results will come later this year, but we can already say that 77% of them say that IntelliJ with the Scala support is their main IDE of choice. And among those 23% who use another IDE as their main one, a bit more than a half still claim that the IntelliJ Scala is their secondary IDE, probably for some hobby projects or for learning. That's a lot. We are very happy, we are very proud, but it kinda also gives us this responsibility on our shoulders so that we don't want to disappoint you. We want to work even more to give you the best developers experience. And yeah, so what is this work? What is it what we talk about when we talk about Scala support in IntelliJ IDEA? It consists of many things. Usually when you just start, when you open IntelliJ, what you see is that you can open or create new project, and it will load in the configuration from some build tool configuration file. Then it will parse the syntax, it will start to index it, and then it will start to highlight your code. But that's not all, that's far from it. We also support certain frameworks and libraries. We help you with compiling, testing, and debugging. We also are a part of a bigger whole. IntelliJ is not only about Scala, which means that apart from having Scala-specific features in IntelliJ, you have also access to many other features that help you in your work, like we have new UI or since recently AI assistance. And we will briefly go through all of them, starting with the framework support, like for example, Play. Usually when IntelliJ parses your code, we stay agnostic when it comes to what this code is doing. If you make a web application, if you make a end-user application with some graphic user interface, or if you make a library, IntelliJ Scala will work the same. But there are certain frameworks and libraries in Scala that are popular enough that it makes sense for us to actually give them additional support. And in this case, we look into that code, we try to understand what it's doing. And for example, if normally you would just see code that compiles and from the Scala point of view looks good, but we have a suspicion that maybe this is not a good Play code, then we can tell you about it. We can also show you how the calls to different Play methods work, what are the results, and so on. Apart from Play, we usually support also different test libraries, like those few. This is fairly standard thing, but there is one more problem here. Supporting such frameworks means for us that when something is changed in that framework, our support breaks and we need to fix it, we need to work on it. So we are kind of reluctant to do it, to add that support directly to the Scala plugin. Instead, the IntelliJ platform supports creating plugins that rely on other plugins, and we also use that. For example, we support VIO with the help of the VIO IntelliJ plugin written and maintained by Igor Tabachnik. And that plugin relies on us, but adds additional support for VIO. And the moment that something changes in VIO, it's simpler, it's more straightforward to fix that support in that small plugin instead of doing it on our side. But all right, let's go to IntelliJ IDEA and let's see how we can help you with your work in other ways. So this is, let's see if I can make it maybe a bit bigger. Okay, so this is a fairly simple example. It's like artificial test. We have a list and map and lazy list here. And we have a breakpoint set at assert equals, because we can run this test, but we can also, of course, debug it. And when we do that, this is too small. Okay. But it will be visible on this way. Okay, on the left, we have a call stack that shows us from where this particular method was called, this test method. So this gives us access to munit, which I'm using right now. But let's pretend here on in the test file that this is actually what we want to test. That, okay, so we want to try if our lazy list, the second element on the lazy list, is free. We can look into elements of the list, of that map, of that lazy list as well, both on the right side with here, but also here in the inline hints. This shows us the same thing in the pop-up. In the case of the list and in the case of the map actually shows us elements as tuples, 1A, 2B, 3C. This shows this list with all the elements. In case of lazy list, which is not computed, it's only evaluated on call, we don't know the size yet, but if we click on here, IntelliJ will evaluate that list for the first 10 elements, and then if you click it again, that will evaluate even more. So yeah, this way you can see what's happening to your to the data under the scope. You can also, because this is because of our support for tests, you can see how that element, is it the same, or if there is a difference, we can highlight it. We can show you better what's the difference between what you expected and what you obtained. For another thing, since we are here, we have support for SBT in the form of course, we can, when you open your project, this will be read in, and IntelliJ will configure project based on that. But also, for example, we have a auto-completion here that tells us if we want to add another test library like Scala test, then IntelliJ will look through what's possible, what is there that you might add. So you don't have to go to the website of Scala test, or you don't have to see it on Maven Central. You can just choose this from here. And same for the for example, the number of the version number. In a similar way, we could do it for Scala meta, probably, but we depend here on some metadata that is not available for all libraries, so we will just leave it here. Yep. Going forward, we have collections we have a lot of inspections that help you with your code. Most of them are fairly simple, but with more complicated code, we always know that we go through the code can become so complex that usually the developer just develops a sort of a focused vision only on some part of it and can completely ignore errors or problematic code in other places. Here, we can go quickly through inspections that just show you that, okay, if you have filter, but then you only want the option of the first element, then maybe instead of filter, what you really need is find. If you have two sets, well, for example, first, that set could be private, and if it's not private, then maybe it should have a type annotation, so let's add it. And also the same for the result. But also, if we want to have a result that is that we filter elements from the first set that only for those that are contained in the second set, that actually means that maybe what we want to use is the intersect method from the collections library. If we use exists method on the collection, but what we look for is just one element of a specific value, then probably we want contains. If we want to filter a collection, but we are interested only in the size of that filtered element, then maybe we want to use count. If we want to find an element, but we are only interested in if it's there, then probably that's exist and not find with if defined. Now, here, for example, we have an undefined method, undefined condition that also we don't know how you want to define it, but we can, but IntelliJ can just highlight it and tell you, yeah, you probably should. Let's make it like this, for example. And now we also know that if you use exist and for all, but there are some negations in your code, and writing that code and refactoring it, it is possible that you will just forget about it, or just add those negations and then add some more negations and add some more code and so on. So we can find those places and tell you that, for example, exists, if there are two negations for exists, then that's just a moment, then that's for all. But if it's for all with two negations, then that's exists. Also, sometimes we can hint at that you will probably get better performance if you switch your methods. For example, sorting before filtering doesn't really make sense. If you filter first, then you will have fewer elements to sort. So let's do it here. We can check if your methods are private, as I already mentioned before. So this can be. This, on the other side, is completely unused, but maybe it will be. Maybe you are writing a library and that method will be used somewhere else. You can either remove it or you can annotate with unused simply. Similar to the collections method, option is also like a collection of only one element or zero. But that gives us additional information that, for example, if we have code that is if something, and then you return an option, and otherwise you return none, then that's equivalent to using simply filter method. And similar here, like if we map over an option and then we use get or else false, then that's exactly the same as if we used exist. But also, in a more general way, map and get or else is equivalent to fault. So that's up to you. You may go to the settings, you may disable that that inspection if you feel that map and get or else is better, more suitable to your style. Or you can let it be, and then you can use it if that kind of code will be in your code base. Also, on the other hand, map and get or else, when the other element is true, is equivalent to for all. Now, there are a few more smarter, more tricky inspections. For example, this one tells you that you have a map over a sequence, and map probably shouldn't have side effects, but you have them. we also don't know what do you want to do with it and should you do it. Maybe there is a good idea, good reason, but we can at least tell you that, yeah, maybe you should look into this code a bit more. And here, well, I know many people have strong opinions on it. Future is not really a monad, but for the reasons of this example, let's pretend that it is. Future is kind of a nested stateful monad, meaning that there is an internal state inside, and that state may change. And if you have such a monad and you put it inside another monad, that may lead to some unexpected results and might be difficult to debug. So that's also like something we just want to tell you, that maybe this is not exactly what you want. And yeah, but for example, if this is a future of an option is not stateful, so that's okay. Another thing we're happy with, and I think this one actually can be useful for many, many people, is that we can, so here we have code that relies on some imports that are still not present in the code. We need the additional import to use a conversion after a collection. We need import to use a future. We need import for seconds, and so on and so on. IntelliJ with the Scala support lets you simply add those imports one after another with simple actions. And yeah, if you add a future, that also means that you should add an execution context. That can be done also the same way. Here we can add extension method as well. Here for sorting we need some ordering, and that's done. All those imports are added here at the end. You can, if this is not what you wanted, you can take it from here and copy paste it somewhere else. Then another thing is that we have, for example, if, where we check the type, and that's not really Scala idiomatic. You can also change it to match case easily this way, the whole code. Or if this is for some reason what you want, but maybe there is one of the branches of if else, then you can change only that branch. And also we have this way to tell you if you have like a chain of methods. We can let you know how the type of that of the collection you're working on is changing from one piece of the chain to another. We can see here that we start with the sequence of ints, then we map it to each int to another sequence, so that sequence of sequences, then we turn it to a set, then we change each element in the sequence, in the set, to a string, and so on, and so on. This actually can be pretty easily configured, because we know that for some people those inline hints about the types can be too wordy. They prefer their code to be more concise. We can turn it off simply. We can then turn it on again by going to the settings, to inline hints. And here you can see that you can turn on and off inline hints for many other options, not only for call chains, but let's keep it here. Also, if you, for example, want to have both worlds, you can turn this off and use our new feature, still in the experimental phase, called X-ray. If you call by default, if you click on comment 2 times and keep it, you will see the inline hints for the types and inline hints for the parameters. And then when you just release the comment, this will go back. Also, if you don't want, if for some reason you want to do it differently, you can just mark the code and then call the type inference this way. Sorry for the small, that sequence of int. If I choose to mark a bigger part of the code, that will tell me what that part is evaluated to. Or I can simply add type annotation here at the end. All right. Now, the other thing is, a big part of our work as developers is compiling. We can go and practice thought fighting, but maybe that's not the best thing to do. Instead, IntelliJ provides compilation charts. So if you, for example, rebuild the project, that's our Scala Ultimate project, you can go to the build here, you can click on the chart, and that shows you what exactly is being compiled in what time and how much memory is being used. So here we see it split into modules. Some modules depend on the other, so they can be compiled only after the previous modules are compiled. We can see how much time that takes. We can also change the level of specificity and see how much in phases, what exactly is the how much time a given phase of compilation takes. This can give you a pretty good information about that, what can be a bottleneck in your code, and like you should maybe go there and work on it to make compilation of that particular small phase or module faster. And that will result in a much faster compilation of the whole project. So yeah, let's maybe stop it. Otherwise it will take quite a long time. And going back, that's compiling. Going back, I would like to say something about the Scala 3 support. We started to support Scala 3 even before Scala 3 became a thing. That's the first release in 2020, where we already had the preliminary support. And from that moment on, virtually with every release except one, we added and improved support for different things in new features in Scala 3. And with every release also we fixed some corner cases from the previous releases. And we were improving, and we were improving. And now we are at the release 2023.2, and we still have some work to do. But if you want to know the details, you can easily go to our blog. I will show you the link and the QR code at the end. And then in the release notes, you can see exactly what's being done. Yeah, but let's also look at an example or two of that in IntelliJ. The main thing, the main thing is the types, but we also have, of course, support for the top-level main method. We have support for enums, and when you just write the name of the enum, then you have in auto-completion the cases of that enum. There is, although the biggest thing and the biggest also feature that we are working on still is the new type system. For example, we have in the Scala 3 those Scala compile ops that lets you make the type very specific, literal. So we have a multiplication value, a multiplication field that is with type 3 multiplied by 5, that's 15. And the value 15 is the only one that this type accepts. If I change anything here, then IntelliJ will tell me that the number 15 cannot be a value for that type. Similar for booleans, we can have a type that is only true, even true and true. If I add false here, that will also mean that the true value is not possible, is not accepted. And even in strings, we can have a literal string that is a type. And here also IntelliJ is able to recognize that we try to assign a value of a different string to the one than the one that is accepted. And that leads to a pretty, funny situations when we can have a type calculator. We can just create a mathematical equation here, and then we can see that we have type t equals 42. But what's more important maybe is that in Scala 3 we have those match types that let us make more interesting, more complex evaluation of types. And in IntelliJ we now also support it. Here we have a type that tells us that if we have like a type that is X that is a sort of a collection, then leaf element of that type will be the smallest element inside that collection. If the collection has a collection inside, then we look again for that inside that type. And here we have two tests that show you that if we have like for example, a result of a leaf element of the string str, then that type will be S, will be a char and the value should be S, and that is supported. We can just run that test. Okay, but this is still in progress. Actually, working on the match types and working on the new type system affects a lot of the Scala 3 support. So we are aware there are still things that needs to be done, and we are very much relying. We very much care about on your feedback. If you have any comment, you can also, of course, go to our booth here at Scala Days. If you if you will want to add something later, you can go to IntelliJ and from the help menu you can submit feedback. You can also go to uTrack, our system for tracking issues, and create a new ticket there, or you can find us on the platform formerly known as Twitter. You can find us on our Discord. And you can, as I said before, you can visit our blog and read release notes and other articles. And that will be it. Thank you very much.